Good evening, class. We're working on proportionality and tables, so go ahead and take out your notes and let's get started. Relationships are proportional if they can be represented by the equation y equals kx, where k represents the constant of proportionality. So we are going to complete the tables below and use the information to answer the questions below. There are two coffee shops in a town that charge different prices. The prices are proportional, but some of the information is missing from their price list. So we have the Seattle Coffee Works and Houndstooth Coffee. These are what we're going to be working on. So the very first thing we want to do is we want to find the unit rate, the per one. So I'm going to divide this, my y. Remember, this is x, this is y. I'm going to divide my y, $8.25, by 3. Y divided by x gives me my constant of proportionality. Bring up my decimal point. 3 goes into 8 2 times. 2 times 3 is 6. Subtract and bring down. 3 goes into 22 7 times. That is 21. Subtract and bring down. And 3 goes into 15 5 times. This gives me $2.75 here. Now I'm hoping it's a constant, right? So let's check this one right here, and we're going to do the same thing. I'm going to divide $13.75 by 5. Bring up my decimal point. 5 goes into 13 2 times. That's a 10. Subtract and bring down. 5 goes into 37 7 times. That's 35. Subtract and bring down. 5 goes into 25 5 times with nothing left over. So yes, that looks like our constant of proportionality is 275, which tells me that I can fill in the rest of the table with 275 here. Now, how am I going to find all of my total costs? Well, if I divided to find it, I can multiply to find my y. And that is where y equals kx comes in. Okay, remember y equals kx is what we wrote right here. Let me give myself some space here. And if I am searching for y, if y is the leading thing I'm looking at, that's great. It's telling me to find the total cost, I multiply 275, because that's my constant of proportionality, times x. In this case, the number 1, 2, 3, 4, 5. So that's what we're going to be doing to figure this out. So 275 times 1 is 275. 275 times 2 is 550. We already have 3. 275 times 4 is $11. We have 5 and 275 times 6. We get $16.50. Okay. Now let's look at this one. Houndstooth Coffee, and they're giving us these two values. So we're going to find that. We're going to find our constant of proportionality by dividing. So let's go over here, and we're going to do $5.60 divided by 2. Bring up our decimal point. 2 goes into 5 2 times. Subtract. Bring down. And we get 280. And then let's try our 6. And decimal point, 6 goes into 16 twice. Subtract. Bring down. Goes in here, 848. Okay, we get the same thing. So we have a constant of proportionality in this one for 280. We're going to do the exact same thing we did on the other side. To find y, we're going to use the formula y equals kx, where y is our total cost and k is $2.80. And we can drop that 0 here, and then we're going to multiply by x. So 280 times 1 is 280. We have 2. 280 times 3 is $8.40. 280 times 4. Remember, you can drop that 0. We just add it back on at the end. We get $11.20. Don't forget you bring in your decimal because we have one decimal place here. Yes, we're going to move over. Let's erase some of this up here. Give myself some room. Okay. And then, sorry guys. I lost my page. There we go. Whew, I was scared for a second. Okay, 280 times 5 is $14, and 280 times 6 is $16.80. So let's go get these in here. So I have $14 I need to add. Okay, so what do you notice is different about the two tables? I notice that their constant of proportionality is different, or their K. Okay, what proves that both these coffee shops sells their drinks at a proportional rate? Well, the ratio y divided by x, or RCOP, is the same. And that is known as a constant rate. Okay. You guys have this all on one page. I have to have it on 2 pages. So if you purchased at 9 cups of coffee, how much more would you spend if you purchased at Coffee Seattle Work? So let me go back. Oh, I erased it. So we had $2.75 per 1 cup of coffee at Seattle, and you had $2.80 per 1 cup of coffee at Coffee Works. So I would do $2.80 times 9. And get 25.20. And then I would do 275 times 9. And I get 24.75. Now it says, how much more would you spend? This keyword right here means what, guys? How much more? I need to subtract. So I'm going to take these two numbers, 25.20 minus 24.75, and subtract. And we get 45 cents more. Sorry, my brain just goes away sometimes. Okay, so now we got this third coffee shop opening up. They must have a lot of teachers in their town because we need our coffee. What do you notice about their pricing structure? So we're going to look at Stumptown Coffee, and we're going to do our y divided by x, which gives us our k again, and we get, guess what? A same constant proportionality. But their coffee is even more expensive. It better be really good. As teachers are broke, we don't be spending pricey coffee. Okay, so, oh, excuse me. Yeah, that was Mrs. Williams assuming. Okay, 290 here. How about we go back and actually do the math? So 570 divided by 2. And it goes in 8 times. That's a 16. Bring down a 0 and 5. Ooh, look at that. 280. Oh, sorry. I love to write in yellow on the side. I hate writing in yellow on the board. Okay, so let's check the 840. divided by 3. Bring up your decimal point, goes in twice. And this one's, ooh, 280. Ooh, I like this coffee shop. We need to do a group purchase. Why would I want to do a group purchase? What do you think is happening here that I said a group purchase would be good? Okay, let's try these last two. 1350 divided by 5. 10, 35, 7. Ooh, 270. And then 1590 divided by 6. 2, 12, 39, 6. Why would I want to do a group purchase? Like if I got a bunch of coffees all at once and like maybe handed them out to the teachers, you know, because the more coffee you purchase, the less each cup costs. Okay. So the cost of a cup of coffee decreases as you purchase more cups of coffee. Which is why we shouldn't assume that a table is just all the same, just like I did, because you know what? Sometimes it's not. Sometimes it's not proportional, and we need to know that. So, what would be the benefit to this structure? If you remember on the first page, Seattle Coffee Works was $2.75 a cup, and I forget the other name. Houndstooth. Houndstooth was $2.80. So if I'm trying to save money and I needed to make a big coffee purchase, if I bought 5 or more cups of coffee, I am going to pay less at Stumptown than either of the other coffee shops. Oh, this goes here. Sorry, guys. Okay. Use your understanding of the constant of proportionality to determine K. If the relationship does not have a constant of proportionality, label it as non-proportional. So, here we go. Remember that the constant of proportionality, K equals Y divided by X. This is our rule when we're looking for the COP. So I'm going to take Y and divide it by X. 6.8 divided by 2 is 3.4. 17 divided by 5 is 3.4. And 27 divided by 2, divided by 8 is 3.4. There is no good way to do this except for to divide, guys. You can't just be like, oh, look, because you know what? If it's not a constant of proportionality, one of those could be different. You have to do the math. And this one is also 3.4. Okay, once you have that math done, you can say that K equals 3.4. It is proportional. How about this one? 3 divided by 1, that's easy, 3. And then I have 9 divided by 4 is 2.25. Ooh, that's a problem, right, guys? So this is non-proportional. As soon as I get one that is out of what it's supposed to be, you can stop because it's not ever going to be proportional. How about this one over here? I'll do, ugh. Sorry, guys. I'll do this one in green. That's what I was trying to do when it got all crazy. Okay, so I do 18 divided by 3, and I get 6. I do 30 divided by 5, I get 6. Oh, I like this. 42 divided by 7 is 6. 54 divided by 9 is 6. So I have a k is equal to 6. This is a proportional relationship. Okay, a fraction can also represent k in a proportional relationship. So we're going to go ahead and take a look at these. Remember, this is y divided by x. K equals y divided by x. What is the constant of proportionality in this table? Well, this first one is 1/3 divided by 1. And so when I write this like this, because this is called a complex fraction, and we haven't really seen this very much this year, but remember that this big one is just a division symbol, so you can write it like this. We do keep, change, flip, and guess what we get? We get 1/3. So this constant proportionality is 1/3. Let's try the next one. K equals 2/3 divided by 2. Complex fraction, we rewrite it using this symbol. And we're going to do keep, change, flip. 2 divided by 6, which is also, 1/3. Liking this. Okay, how about let's do the third one. 3/3, which is 1. So 1 divided by 3, yes, 1/3. Okay, how about 4/3 divided by 4? Rewrite that. Keep, change, flip, multiply across, simplify. We also get 1/3. I'm going to do this one off to the side. 5/3 divided by 5. Rewrite it as a regular fraction instead of a complex fraction. We're going to keep, change, flip. We get 5 divided by 15, which is also 1/3. So our constant of proportionality in this one is all 1/3. K equals 1/3. Okay, each table shows a proportional relationship. Fill in these missing values, determine K, and then summarize today's lesson in 2 to 3 sentences. Make sure you're talking about complex fractions, how you can change it, things like that, what a proportional relationship is, the 2 types of equations we're using, and I will see you guys in class tomorrow. I hope you have a great